The one-way analysis of variance model can be extended, so rather than just looking at multiple groups in a single factor, we can take into account additional factors in our experiment. The simplest extension, going from one-way to two-way analysis of variance, introduces a second factor with a number of levels, as well as a consideration of the interaction between the two factors. So we'll be looking at R Commander and how you can fit a two-way analysis of variance model. And the example we'll use is one where there is a company that ships parcels between its various offices. So we've got 5 sub-offices in this example, and there are 3 potential parcel delivery services under consideration. So what the experiment was doing was shipping 3 parcels from each of the 3 carriers to the 5 offices, and looking at the average delivery time to see whether or not it's consistent between the different services and the different destinations. So we import the data. It's from a text file, and it's comma separated text file. Click OK, select our delivery.csv, and now our data has been loaded into R Commander. So it says at the bottom 45 rows and 3 columns. So we've got our 2 factors, service and destination, and the time that it took to deliver the parcel. So what we might want to do is to take a look at the average delivery time for each of the offices and do those calculations for each of the services that are in use. So what we would do there is a plot of the means. Our response variable is time, and the 2 factors we're looking at are service and destination. So we'll calculate the mean time for those combinations and put information on based on standard errors. So we can see from our plot that for the 3 carriers there seems to be a consistent difference between carrier 2 and carrier 1. The situation with carrier 3 is a bit less consistent. So what we're going to do here is to test whether there are actual differences between the carriers, if there are differences between the offices, which it looks like there are, and whether there's an interaction in there, which this green carrier 3 suggests there might be. So we do statistics, means, multi-way analysis of variance. We select the 2 factors that we're interested in and look at the response variable time. So then if we scroll up the output, we can see the analysis of variance table for this model. So, is there a difference between the destinations, the 5 offices? Yes, we've got a very small p-value, so it suggests that on average delivery time is different. So we've got our 3 services, and again we've got a very significant test here with a very low p-value, suggesting that the 3 carriers are different in terms of the time that it takes to deliver, and the interaction between the 2 is also important. So the difference between the services depends on which office they're being sent to, and similarly the difference between the offices depends on which service is being used. So then we've got a few summary tables. So we've got a table of means for the offices and carriers, so we can quickly see here that carrier 1 appears to be the cheapest. It appears to be the cheapest for all of the delivery destinations. And then here we've got information about the standard deviation, so how consistent the delivery times, but we've only got 3 observations here for each of those combinations, which is shown in this last table. So we can then, as with a lot of models, go to the models graphs, basic diagnostic plots, and we can see that the residual diagnostic plot looks reasonably good. There are only a couple of observations which are slightly out of tune with the rest of the data. The assumption of normality for the residuals, sensor data, is also okay for this particular data set. So we can see it basically falls on the straight line.